previous generation, which are very good and fast computers, we're actually having a jump up in performance. The relative performance number is 583. Now in the year 2000 we had a RS6000 computer that was the same size as the S924, and that was rated as 1, so in those 18 years the computers are now 583 times faster. But let's give you a number you can probably remember. If you compare the Power 8 and the Power 9 computers, our jump in performance is between 40 and 47%. Some of our competitors release a new generation of their computers if they get above 5% extra boost. So this is quite a jump from IBM. Fact number 9, how fast can we push these chips? We're running these at 3.9 to 4 gigahertz, and the competitor tends to run their server-based chips at about 2.5 gigahertz. So this shows us how IBM's superior engineering actually gives us that performance advantage. Fact number 10 is that the S924 has a smaller brother than the S922. It's only 2U in a rack instead of 4U in a rack. This means we can't get quite as much air through the box at the front there with the fans. It means the number of CPU cores goes down to 20, but you do get twice as many computers in a rack. So here's a little summary about the 10 facts about our CPUs for the Power 9 S924, in case you want to make a note. In my next video we'll be looking about facts about memory. Hello, my name is Nigel Griffiths, I work at IBM, Power Systems Advanced Technology Support in Europe. This video is all about the Power 9 scale-out machine, model S924. This is the first look around the machine. I'm going to point out some of the highlights of the machine on a couple of slides, and then we'll actually have a look at the front, the inside and the back of the machine itself. So this is the front of the machine, and I must say it's very nicely made indeed. 19 inches across and 4U high standards for the size for our machine. There is a 2U high version of this machine, the S922, we'll look at that in a second. Inside the box we have the Power 9 processor with 8 billion transistors, quite a big hike from the previous generation. In the scale-up machines we have 1 or 2 sockets. It's up to 24 CPU cores in here, and it goes up to 4 gigahertz. Around the base of the Power 9 heatsinks we have 32 DIMMs. They are DDR4. That gives us up to 4 terabytes. They can be various sizes from 16 to 128 gigabytes. At the back there's a stack of 4 small power supplies. This will allow the machine to actually run with just 2, so you can actually have 2 failures, or 2 of the cords fail, or a PDU fail at the back of your rack, and you can carry on running. At the front there are 6 air moving devices. They're not actually fans, we'll look at those in a second when we pull one out. At the back we have up to 11 PCI adapter slots. 5 of those are generation 4 for extra performance. There are many storage options. This diagram is actually showing you a split disk configuration where you can have 6 disks in one operating system and 6 disks in another. Typically used with Power machines to boot the 2 VIO servers that are supporting everything else. There's also space over here for an RTX drive, which is a removable hard disk. That's a pretty nifty, cheap and cheerful backup option. You can also run it as 18 disks, and then we have advanced caching and array controllers for extra performance and functions. Of course, with Power, you can use the fiber channel adapters in the back to connect to your SAN disks. The internal disk can be regular disks or solid state drives, and we also have a new option for 4 NVMe drives, and each of those 4 can go into different operating systems if you want. Then we have remote I/O drawers for more disks and more adapters. So that's the S924, but it has some friends. We actually have 6 machines in this range. There's the S922, which is 2U high. Of course, you can't cram quite as much stuff in the smaller box, but that can be very useful. Still has the 4 terabytes of memory. Then we have the L922, which is the same again, but for Linux only environments. Then we have a S912, which is a cut down S922. If you don't need all the CPU power and memory, then you can take that model instead. There's also 2 H models which are used for running the SAP HANA environment in particular. SAP HANA, of course, runs on Linux, but you are allowed up to 25% of the CPUs to use AIX or IBM i. Well, that's enough talking about the box. Let's go and have a look at the one I actually have in a rack here in London, in the UK. We've been using this machine for 3 months now, and we're very pleased with it. I noticed while editing this too bright you can see the S924 on this little strip sticking out the front of the machine. Here's the power button and LED, then we have the 3 LEDs, blue identity, and 2 for system fault and system roller. We have a little blue tag in here and here, that's used to pulling the bezel off, we'll do that in a minute. Looking at the discs, we have D1 to D10 in here. The first set has 6 and another 6 because we have a split black plane. This is the one running the first VO server, this one here is running the second VO server. Dual disc would be better. Over here is where an RDX is optionally placed. There's a small USB connector in here. There's the ops panel LCD here, it's missing on this particular machine. We'll come back to look at that in a minute. 6 blowers or air moving devices, as IBM prefers to call them. Down in here, this is actually connected to the machine rather than the bezel. This, if you like, is the handle that you pop down and pull if you want to move the machine out of the rack on the rails. Up in here, difficult to point to this is a new Power 9 logo, blue and green circles around it. Further down in here there's a little hole in which you can push an earth connector if you want to earth yourself to the machine before doing maintenance. Now pull those blue tags, it comes off with spring clips. You can see a little bit more of the internals here. Mentioned the indicators, they're still here, they're connected to the frame, and the 2 handles for pulling it out, we'll do that later. And the earth position. You can see the 6 blowers in here with bright green LEDs. They're chamfered so that they go into the machine at the bottom, so the handle will fit in there, doesn't stick out the front. Now you can very quickly pull out a fan if you want to. You can see it's a centrifugal fan in here, quite large, so that the noise is quite reduced. We can just pop that back into the machine. Need to push it in a little bit more, and then move the handle. It also popped up an orange LED, you can't quite see it there, there it is. I was told the HMC that something odd happened with the fan, but it's working again. In here is where the LCD optionally will go. You can order those or not. If you've got hundreds of machines, you're not going to be fiddling about with the LCD and the 3 little buttons. You can see the same details on the HMC remotely. Right, I'll now move the machine out on the rails, so we can then move the camera and look inside the machine. So here's a view of the top, the 2 fantastic stickers on here, giving you lots of information. At the front we have the details of the DIMM slots. Socket 1 is over here and socket 2 is over on the right, and the DIMM sockets and breeze catches are different colour combinations and they're very clearly numbered on the top. On the larger sticker we have the adapter slots and their numbers, and the same for the discs at the front of the machine. Very good for customers and customer engineers. Set the lid off, press the blue catch, raise the little handle, the lid slides back about a centimetre, and then we lift the lid off. Just pointing out how good these labelling are. Fantastic when you try to work out which is adapter slot, C7, etc. And we can see in here there's a big plastic cover and air down to improve the airflow inside the machine. So we'll move the camera so you get a better look. Okay, that's better. You see this big plastic cover in here, this is to increase the airflow across the DIMMs at the bottom and around the heat sinks for the main CPU's power lines. So we can grab hold of the plastic air cover and just pull it straight up. Hard to do. We can see inside the machine. Obviously the 2 Power 9 sockets at the bottom here, great big heat sink. At the bottom there's the copper that actually connects to the processor and the big clamps. These are two voltage regulators in the copper in here. These protect all the electronics from problems with the power supply and actually power the machine down rather than letting it get damaged. Looking around, everything is very neat and tidy, well engineered. Now we have lots of DIMM slots, 16 for each socket. You can see here that some of the DIMMs have black handles and some of them have white handles, and the actual socket itself with different colours. Those combinations tend to mean that you get the right ones when you actually changing the memory. We also have plastic inserts for dummy DIMMs, if you like, or when we haven't got a real DIMM in a socket. This increases the airflow around and down. Behind here in front of the camera, if you like, is the back of the disk drive. There's a small motherboard there that do the connections. 4 power supplies in the middle-ish. Over here there's 7 PCIe adapter slots. Here there's 5, so it's not quite symmetric. The last one over here is the service processor with some Ethernet at the back in here. Battery, and this is the VBD with your activation codes. As we call it a lollipop. You can't really see it behind the heatsink. Down in this corner there's the light path diagnostics button that you press to see if there's any problems. This cage item in here allows a lot of airflow, but it gives us a lot of rigidity to the chassis. Along the sides of the DIMM slots, the DIMMs are plastic runners, there to force the air to go down past the memory and not escaping behind the CPU heatsinks. A few capacitors and things dotted around on the motherboard. There's a few cables running front to back. They're all tucked away out here, so it doesn't interfere with any of the airflow to keep the memory and the CPUs nice and cool. So I'll put the air conduit or air dam, I'll have to go and look up the official name for this, back into the machine. Just popped in nicely. Then we'll get the lid. Pop that down 1 inch back from where you want it to finally be, 1 centimetre. There's a metal pin that sticks up through the handle in here. Let's zoom into that silvery thing there. That's sticking up, then you've got it in the right position. You pop that down and it all slides back into position. Left and right, press the buttons in and then give it a little gentle push in, and then we've released those, so we'll go straight back into the machine. Excellent. Now just dip over here and get the bezel, and we'll pop that back on the front, get it in the nice right position, and give it a little sharp tap over it. We'll see that the warning light's on. That's because I took the fan out, so it all looks good. Meanwhile, around the back of the rack. Okay, so let's have a quick look around the back of the machine. We're trying to keep things nice and tidy. This is the cable management arm, so we loop back and forth, and then the cables actually go to the machine. Got nice little clips in here that keep all the cables down together. We're putting our Ethernet in a bundle, our fibre channels in a bundle, and the power supply. That tends to ease the pressure so we don't break any fibre channel cables. Here we go into the 2 HMC ports on the back of the service processor. 4 power supplies, higher rated than in Power 8, we've noticed, and then we have the airflow ducts, a bit like the Power 8 machines in here. Plenty of air can get out the back of the machine to keep the internals cool. There's a big Velcro attached here so that we don't have the power supply drop out if we move the machine. Now this cable management arm is connected to the back of the rack here, the back of the machine here, and the back of the rack in here, and you're thinking, well, how on earth is that going to work? There's something fundamentally wrong in here, but we can show you a little bit of magic here. 1, 2, 3. Abracadabra. So the middle of the arm slides down that little runner there and straightens out so that it can get it right out of the front of the machine with the machine still running, so we can do live adapter swaps and those sorts of things. Then Mike will give it a push back, and back it comes in. It's great, isn't it? We are really impressed with this piece of engineering. It took about 30 seconds to install it. So that's the first look at the S924. What are our impressions? Excellent engineering. We can see we're making improvements for reliability. Everything just seems to install and run, and it runs quickly too, with 0 changes to the applications. Some of my programs are from Power 6, 7, 8, or just run with hammer.